I'm Will Shirtliff, and I will be co-presenting today with Nick Capelli. Okay, so the subject today is serviceability of EV battery packs, and today we'll start off with a short discussion of who Parker is, just a quick overview of the company, then we'll jump into it. We'll talk about serviceable packs and serviceable materials, then we'll get into non-serviceable materials, then we'll have a short discussion on end-of-life disassembly. We'll talk about some key takeaways. And then at the end, we'll have a questions and answers. Be sure to submit those as we're going through in the Q&A box that's at the bottom of your screen. Also, you can join us via Twitter if you tag us at Lord Corporation or at Parker Sealing, or use the hashtag EV Battery, and you can join the conversation that way, and we can interact via Twitter. So Parker as a whole, Parker Hannifin Corporation, headquartered in Cleveland, Ohio, is a giant corporation. We've got 3,000 product lines. We've got $14 billion in sales, 56,000 team members around the globe. But we organize ourselves in a way that we have individual operating groups, so we can really focus on customer needs, products, and markets. So the operating group that we're a part of, everyone on this line, is Parker Engineered Materials Group. And we as a group are focused on sealing, on shielding, coatings, thermal interface materials, adhesives, along with other products. In 2019, Parker acquired Lord Corporation, and they joined the Engineered Materials Group and brought their extensive history of working on electric vehicles and a broad product line, as well as strong engineering capabilities, to the Parker team. Parker is a collaborative partner to you. Our goal is to work with you on your designs to meet your specific needs with custom products, to provide continuous process improvements, and to support your cost targets with value and function. Also, another goal that we have is to support you globally. We have manufacturing facilities throughout the world. One objective that we have is to be everywhere you need us. So we have facilities, you can see from this map, we have facilities all over North America, South America, Europe, Asia, as well as other locations spotted throughout the world. And we're continuously expanding that. I mentioned the acquisition of Lord Corporation. Parker has grown every year I've been with Parker, and are constantly looking for new places and new ways to support customers around the globe. Parker has a strong focus on electric vehicles. One of the objectives that we've had over the last 5 to 10 years is, as the electric vehicle market has grown and expanded in importance, and as its role within the automotive industry has increasingly been shown to be the future of the transportation market, we have made an objective to be able to provide solutions throughout electric vehicles. And this is true on the power electronic systems, the electric motors, throughout the charging systems, and on the battery packs and the battery modules as well. And it's on the batteries that we're going to focus here today. I want to start with a quick definition of what we're talking about when we say serviceable, non-serviceable. Serviceable, the idea there is that you have a pack that can be opened once it's in the field, can be removed, reworked, repaired. This is very useful for any kind of aftermarket challenges. You have a mechanic that can open it up and make changes. Non-serviceable is you have materials that once applied, they remain for the life of the part. So it makes opening and closing that battery much more difficult. So now I'm going to focus on why serviceability is important. Batteries are one of the most expensive components on a vehicle. If you have even any sorts of damage that take place on that electric vehicle, and it ends up creating issues within that battery, whether it's wiring or in the cooling system, whether it's somewhere within the adhesives or any kind of issue inside that battery, to make a change or make an adjustment is a very valuable thing. It makes it easier on the mechanic. It makes it easier for the customer, reduces cost. If that car is still under warranty, reduces the warranty cost for the OEM. So having that very expensive component be serviceable is a great benefit to everybody in the process. Now, there are challenges to that. There's a reason why some batteries use non-serviceable materials, and those relate to space constraints. They relate to simplicity and the costs associated with the construction of the seals, as well as balancing adhesion with serviceability. In addition to that, there are some risks associated with servicing that battery, including deformation of the cooling plate during maintenance. And so our objective as Parker Engineered Materials Group, our objective is to provide solutions to try and reduce some of those risks and to make it so that serviceability can be achieved without loss of function, without dramatic increase of cost, and so you can get the benefits of that serviceability. So one of the first things I'm going to talk about is sealing. Parker has a wide variety of sealing products for batteries that are serviceable. And when it comes to batteries, you have seals that both go around the perimeter. You have seals internal to the battery. You also have small seals that function as connector seals or header plate seals on those batteries. The perimeter seal is the biggest seal that you have on the battery. Goes all around the perimeter, as the name suggests. Typically, those would be molded or extruded seals. Extruded seals have a benefit of being able to be hollow. And so when you think of the function of a battery and being able to bring that joint together without having a lot of load in that joint, having a hollow seal can reduce that load and make that closure force as low as possible. The benefits there is that it can deal with a lot of tolerance variation. So keeping flatness on that flange often is a challenge. And it also prevents creep over time by reducing the amount of load that it takes to hold down that flange. In addition, any kind of internal seals, regardless of the fluids that you're using, we have seals that are compatible with almost any fluid that is used within the electric vehicle market. In addition to that, as I mentioned before, connector seals and port seals on the outside of the battery, we can supply as well. We have a wide variety of materials that can support each one of these seal designs, both from a temperature capability, a fluid compatibility, and from a flammability perspective. Parker can support all of your sealing needs. And we can do this in a way that that is completely serviceable. These materials can be opened and closed. Often the seal can even be reused, but the installation and removal of these seals are very easy and not a difficult process for a mechanic to deal with out in the field. One of the pushbacks on the use of molded or extruded seals, especially for the perimeter seal, is how to install it. So one of the big benefits to a dispensed seal, for example, or adhesive that goes around the perimeter is that it can be automated. So one of the things that Parker has worked on is making that process easier for customers. And we have generated a variety of different options for customers, and we can work with you, with your system and your facility to make that as easy as possible. And we found that we can often, for high volume applications, we can often make that almost as fast as a dispense seal and almost as painless as that process. And for low volumes, in many ways, it's easier because you don't need to have robotics to install it. You don't need to have any kind of manual difficulties with trying to dispense a seal. These are very easy to install by hand, which makes it easy if you're dealing with prototype volumes, if you're dealing with a specialty vehicle that has low volumes. And then once you get out in the field for service, obviously it's very easy for a mechanic to service that way. So this time I'm going to turn it over to Nick, and he's going to talk about serviceable gap fillers, and then he's also going to get into the non-serviceable materials as we go forward.
Thanks, Will. So talking about serviceable gap filler solutions, for anyone unfamiliar with what a gap filler is, it is a material that dispenses in a bead like an adhesive, but of course, because you need a serviceable material, The idea with the gap filler is that you can remove it easily so that you can replace a cell that goes bad or maybe a full module that goes bad, depending upon your design. So here we have 4 of our different gap fillers, both silicone and urethane in chemistry, that we've tested and have shown low pull-off stresses when measured by a vertical pull-off test that you'll see on the next slide. Now, for the future, we see this pull-off stress even decreasing further by about 25 to 40% for the newest CoolTherm gap fillers. So how do we measure pull-off stress? So try to imagine a battery pack and you have very little space. There are constraints to this, obviously, as Will has mentioned earlier. So the best way to remove a battery is to just pull straight upward. So to mimic this in our lab, what we've been doing is we've been taking these T-bar samples that you can see here on the left, and then taking one of our structural adhesives, and then gluing a disposable aluminum plate to the T-bar. The idea here is that typically we reuse T-bars, so we're sandblasting the main surface, but here by gluing a separate piece of aluminum to the T-bar, you have a fresh, new, untouched aluminum surface that can more accurately measure the true pull-off force needed to separate the battery from the gap filler. And that's shown in the second picture. And then what you do is you dispense a layer of gap filler on that new aluminum plate in the center of the T-bar, using 2 spacers, one on each side to dictate your bond line thickness. Then you of course have the other T-bar on the opposite side, and then you just pull in both directions, thereby measuring the pull-off force required to separate the gap fillers by either cohesive, adhesive, or some thin layer cohesive failures. Now that we've finished talking about serviceable packs and serviceable materials, let's move on to the non-serviceable materials. So when are non-serviceable materials used? In battery packs, I don't think you'll ever find an example where the entire pack, at least for a full-size electric vehicle, is non-serviceable. And this is because eventually over the lifetime of a battery, something will go wrong, whether it's a whole module or an individual cell. So I don't think any OEM is taking the risk to have their entire pack be non-serviceable because they realize that maintenance may be needed sometime in the future. But non-serviceable materials are used just within battery modules themselves. So if you look at the picture on the right, you can see that you have a battery, and underneath that battery, there's a non-serviceable material, usually a nice structural adhesive that will bond the battery to the module housing. And then from there, you have the module housing, which is connected to the entire battery pack housing and to the active cooling system. And this active cooling system is mated to the module and the battery module by the serviceable gap filler that we've already talked about. So moving to whether or not you want to use a non-serviceable or serviceable material is really dependent upon the OEM. Typically, it's cost-driven, infra-module. So some of our customers will see that the non-serviceable materials typically have lower thermal conductivity, and that's what drives them to be lower cost because thermal conductivity and cost tend to correlate. So as a result, they may want to use as little of the serviceable material as they can, and instead think for maintenance cases later that they can just repair an entire module instead of having to repair individual battery cells. This also ultimately, using non-serviceable materials, eliminates the needs for mechanical fasteners in the modules themselves. So there is a decent cost savings by reducing those and just using adhesives. Before the conversation of serviceable versus non-serviceable gap fillers really came up, the first question was, what chemistry do our customers want to use? At first, all of our gap fillers were silicone gap fillers, but we learned over time that some of our customers want better adhesion, and silicones do tend to have poor adhesion to most substrates. And then we also learned that some of our customers have not been interested in using silicones because of volatile siloxanes. And volatile siloxanes are known for affecting the adhesion of other materials such as paint. And of course, for an automotive OEM, making sure they have a nice looking paint job on their vehicle is extremely important. So some OEMs want to avoid these volatile siloxanes completely. As a result, the idea of starting to develop urethane gap fillers was started. And then from there, we realized that urethane chemistry has the added benefit of being flexible in being able to create both soft or serviceable materials, as well as hard or non-serviceable materials. So that's how this product, CoolTherm UR2000, came to be. It's a 2 watt per meter Kelvin thermally conductive urethane gap filler with a 1-to-1 ratio that has been UL 94V0 tested and approved, but it's a harder material so that it acts somewhat like a structural adhesive, whereas the other gap fillers that we mentioned previously are all the soft materials that are easier to remove. And then moving to our other adhesive solutions that we offer for our non-serviceable materials, we have a number here on the slide. So the first one is our CoolTherm TC2002. And this is actually what's pictured in the picture to the right. So this adhesive is a thermally conductive structural acrylic adhesive that is used to bond battery cells to the cooling plates, heat sinks, or active cooling systems within an electric vehicle. So this is a great product because it has a benefit of being a great structural adhesive, gives you incredible performance to bonding to the metals, as well as transferring the heat out of your cells so that you don't go into a thermal runaway situation. Then moving to AC901 and AC902LC, these are both UV cured acrylic adhesives that are used typically to bond plastic housings or coverings to the sides or outsides of the battery cells within the battery pack or within individual battery modules. What's great about these is that they have great adhesion to both the plastics and the nickel-plated steel that's used in the batteries. And they also have the added benefit of being UV cured, so there's extremely high throughput in manufacturing because curing of these materials can take place in a matter of seconds. The difference between the two of these is that AC901 is a low viscosity adhesive that fills in spaces very easily, whereas AC902 is a more thixotropic material that can be dispensed in a bead and in specific shapes. In our third category here, we have MaxLock MXT6 and Lord 5206. These are both acrylic structural adhesives typically used to bond metal supports to battery modules or to the battery pack. Sometimes also plastics as well, though they do typically target metals because our acrylic adhesives are very good at bonding to metals that are bare and untreated. And then finally, we have Lord 7545, which is a urethane structural adhesive that is typically used for bonding plastic housing and supports within the modules and also within the entire battery pack itself. All right, so of course, we've talked about serviceability and some non-serviceable materials. Now let's talk about the end-of-life disassembly, because this will be important for the future of electric vehicles and reusing components. LokRelease 800 is the main product that we've seen used in the end-of-life disassembly for battery packs. It's a solvent-based stripping solution that allows for the removal of non-serviceable materials. So instead of having to bend or break your components, what you're doing is essentially chemically dissolving the adhesive so that you can reuse the parts. As you can see in the video, you see a couple coupons bonded with TC2002, and then when soaked in the LokRelease 800 for a period of time, you can see that the adhesive has dissolved and actually is sediment now at the bottom of the vial, and the substrates can then be removed and are now clean and ready to be reused. This, of course, will allow for cell recycling and recovery in the future. As far as performance goes, we've tested LokRelease 800 against a number of different chemistries, and we found that it's very effective against the acrylic and urethane adhesives that we typically find in battery packs anyway. So that would be our TC2002, our AC901 LC or AC902 LC, our MaxLock Lord 5206, as well as our 7545, all popular products that are being used in EV battery packs today. We also have done some testing against epoxies because epoxies, of course, are very popular adhesives as well. And we've found that this does very well against epoxy adhesives. So here we have the description of the battery recovery process when using LokRelease 800. So it comes ultimately down to 3 steps. The first is that you discharge the batteries. Of course, for safety reasons, you don't want to have any sort of current flowing through these batteries while you're trying to clean them. So we recommend discharging first before you do anything with the LokRelease. Okay, so the second step in this process is to soak the parts. Before you do this, make sure that you disassemble all mechanical fasteners from the device and then submerge the parts in a bath of LokRelease. You can also add mechanical vibration to increase or accelerate the effectiveness of this treatment. Next, cover the bath to prevent evaporation and then cap with nitrogen or argon for added safety. As far as length of time, the length will depend upon the chemistry, the geometry, and how exposed the bond line is to the LokRelease 800, but in general, it typically is effective in less than 2 hours, and of course that can be speeded up with mechanical vibration. Finally, you come to step 3, where we're actually separating the cells and the adhesive residue. So you're going to remove these cells from the LokRelease bath and then rinse, and then the adhesive should be sediment at the bottom of the bath, at which point you can just filter it out. And then what's great about LokRelease too is that it can be reused for, on average, up to 10 times before you need to replenish the bath with fresh material. So finally, let's go over the takeaways from today's presentation. The first is that keeping packs serviceable can improve the life of the battery pack, the customer experience, and the speed of EV adoption. As far as increasing the life of the battery pack, if you can have a serviceable material and a cell or a module goes bad, instead of having to replace the entire battery pack, you can replace just that cell or maybe just that module. That way, your entire battery pack itself can last for longer throughout the lifetime of the vehicle. Regarding customer experience, no one wants to pay for replacing an entire battery pack whenever there's just one little part wrong. So by allowing customers who are buying these vehicles to have lower maintenance costs, it not only improves their experience with electric vehicles, but thereby it also may improve the speed at which the everyday person starts to adopt electric vehicles, because they may realize that maintenance costs are lower than they had ever imagined. And with the decrease in complexity or number of parts from electric vehicles versus the internal combustion engine car, it again may lead to an overall decrease in maintenance costs for everyone, thereby increasing the speed of EV adoption. Number 2 is that packs can be made serviceable with many different materials. Some of these are molded and extruded seals and gaskets, and the others are serviceable gap fillers. So our final takeaway is that non-serviceable materials in battery packs also have benefits. First, touching on eliminating the need for mechanical fasteners, there are many different benefits to this. The first is that you can start to reduce the weight on your vehicle. Of course, everyone is looking to take a pound away, and by eliminating these metal fasteners, you're reducing weight when you're replacing them with adhesives, because the adhesives are going to be lighter than the mechanical fasteners would be. Also, you can reduce the time in which your pack or your module is put together, because instead of having to insert and screw in each individual fastener, you're just having one piece of automated equipment dispensing beads along the pack and then mating the substrates. So your time to assembly will also be faster. As far as using non-serviceable materials, intra-module, they also still allow for your pack to be serviceable, but then to reap other benefits like structural adhesion to the battery and to the module housing. And then instead of using a serviceable TIM, for example, which may be more expensive because of the thermal conductivity, you're able to still use a non-serviceable material between the battery and the module, which ultimately may decrease your cost for that adhesive. With that being said, we can now open it up to any questions that you have.